Good afternoon. In today's session, we have to study about the strain gauge interfacing with Arduino Uno board. We will wait for other students for 1 minute, then we will revise, then we will start our today's session. Until that, we can revise our previous session. In previous session, we have studied about the LVDT interfacing. हमने क्या देखा है लास्ट लेक्चर में LVDT. This is the linear variable transformer. So we have seen how we have to interface LVDT with Arduino Uno board. LVDT's output will be analog and that value is in between 0 to 10 volt. So we have to use voltage divider circuit to divide the voltage to convert 10 volt value to 0 to 5 volt, because in Arduino Uno board there is inbuilt ADC at the A0 pin, but it can read only 0 to 5 volt voltage. इसलिए हम क्या कर रहे हैं, LVDT में हम जब LVDT at mega 328 से interface करना है, at that time we are using here voltage divider at the output of LVDT to convert 0 to 10 volt range into 0 to 5 volt range, and then we are using here ADC to convert analog value into the digital.
सर बोला ले
Please mute yourself. Okay. So we are using here voltage divider circuit to convert 0 to 10 volt range into the 0 to 5 volt, and we are giving this output to the analog A0 pin where there is an inbuilt ADC. So ADC will convert that analog value into the digital, and that output will given to the digital pin. These are the receive and the transmit pin, and then we are giving that response from the Arduino Uno board to our CPU. So we can use here RS-232 cable and the USB cable to give our data from analog port to the CPU. You can see the program here. So in setup function, we are assigning analog pin A0 as a output. Then we are selecting the baud rate, because we are using here Arduino Uno board in which it is compatible with 9600 baud rate. Then we are printing here serial.print in LVDT interface. It means what? Here we are doing LVDT interface with our एटमेगा बोर्ड. हम क्या कर रहे हैं, ऑर्डिनो ऊनो बोर्ड में जो कंट्रोलर है उसके साथ एलवीडीटी को इंटरफेस कर रहे हैं. सो हियर वी हैव टू इनिशियलाइज. So we can do initialization in the void setup function, and that setup function will run only once. After execution of that, execution will go to the while loop. You can see here in while loop. In while loop, what we have to do, we know while loop will execute again and again until the life cycle of program. So here what we have to do, LVDT will use to measure the value of displacement, and that value will be given to analog A0 pin. So here when we will start our while loop, at that time we can use here syntax like a serial.print, and here in serial.print what we have to do, here we are interfacing LVDT, and LVDT will measure the displacement. So here we can write serial.print in bracket double quote displacement equal to, and that value will be given to analog pin. Which pin? A0 pin. So we can use here serial.print analog read A0. It means what? The value that will be given by LVDT's output will be taken at the A0 analog pin, and that pin is nothing but A0, and it is used to convert analog value into the digital. And again what we can do, we can give here delay. मतलब जो हमें यहाँ पे 0 से 5 वोल्ट में वैल्यू जो आ रही है ये A0 पे, that will be seen here, and that will be seen by some amount of delay. We are giving here 1000 milliseconds. This is, you can say, 1000 milliseconds means you will get here the seconds data. Now we can see strain gauge. So strain gauge is a register and that is used to measure the value of strain on a object. Strain gauge is a sensor whose resistance varies with applied force. मतलब strain gauge है वो क्या यूज वो उसका क्या यूज है? This strain gauge can be used to measure the value of strain, and strain will be because of force or pressure or a weight. मतलब okay हाँ काशी. Okay, you can see here. We are using here, what we have to do, we have to interface strain gauge with Arduino Uno board. So we are using here strain gauge, and that is used to measure the strain, and that strain will be because of force, pressure, weight, and that can convert value into the change in electrical resistance. It means what? The value that will be measured उसमें वो हमें कन्वर्ट करके दे रहा है. सो वी कैन नॉट मेजर स्ट्रेन डायरेक्टली, सो वी हैव टू कन्वर्ट दैट प्रेशर, फोर्स, वेट into equivalent electrical resistance that can be measured. So here, when we apply any external force to the object, what will happen? If we are giving force on any ball, any rubber, what is happening? Sometimes what will happen, that object will get compressed, and sometimes that object will get stretched. मतलब क्या हो रहा है? जैसे तुम फोर्स दोगे वैसे उसका शेप चेंज हो रहा है. So what we can say, when we are giving external force to any object, that time there is a deformation occur, and that deformation will be in the form of चेंज ऑफ शेप. मतलब उसका शेप जो है वो चेंज हो जाएगा. दिस डिफॉर्मेशन इन द शेप विल बी कॉम्प्रेसिव और अ स्ट्रेचेबल टेंसाइल. इट्स कॉल्ड अ स्ट्रेन. मतलब जैसे तुम फोर्स या प्रेशर दे रहे हो, एट दैट टाइम इफ इट्स शेप will change. If it means what? The object will get stretched or object will get compressed. So here strain gauge we are using that will convert that value into the electrical resistance, and that will be measured by strain gauge. So here stress is defined as it is the internal resisting force. It means what? Whenever you are giving force, there will be some internal resisting force with that object. मतलब जैसे हम वो ऑब्जेक्ट पे फोर्स करेंगे तो उसमें जो इंटरनल फोर्स होता है, we are calling that as a stress. And strain is, it is the displacement, or we can say it is the deformation that can occur in the object when we are giving, we are applying any force on any object. At that time, if there is displacement occur or deformation of object will happen, then we are calling that as a strain. So here we can say strain gauge is a sensor whose measured electrical resistance varies with changes in strain. हम क्या बोल सकते हैं कि it is a electrical resistance whose value will changes with respect to strain, and strain is nothing but it is the displacement or a deformation. So strain is the deformation of material that will result from stress, because when we are giving force on any object, at that time there will be some internal force. So here stress is the force applied to material or any object, and it is divided by cross sectional area, and cross sectional area we can denote by letter A. We can see here. So strain gauge will work on the principle of electrical conductance. because it is related with electrical resistance, because strain will change value in the form of electrical resistance that will be measurable. So here we can say strain gauge work on principle of electrical conductance, and it is depending on conductor's geometry. It means what? Whenever conductor will be stretched or whenever conductor will become compressed, at that time there will be change in geometry. Because जैसे तुम फोर्स दोगे वैसे क्या होगा, ऑब्जेक्ट का जियोमेट्री, उसके डायमेंशन चेंज हो जाएगी. एक तो उसका लेंथ बढ़ जाएगा if it is stretching, and if you are giving force and that object is compressing तो उसका लेंथ जो है कम हो जाएगा. So whenever conductor is stretched within the limit of elasticity, it does not break. वो टूटेगा नहीं, but what will happen, it will become compressed or it will become stretched. In another language, you can say it will not break, but it will become narrower or a longer. Similarly, if that object is compressed, so it will become shorter and a broader. Ultimately, there will be change in resistance, because we know the value of resistance is depend on the length and cross sectional area of object. क्योंकि हमें पता है रेजिस्टेंस का जो वैल्यू होता है वो ऑब्जेक्ट के जियोमेट्री पे डिपेंड होता है. सो वी कैन से हियर द वैल्यू ऑफ रेजिस्टेंस ऑफ ऑब्जेक्ट इज directly dependent on length and it is inversely proportional to the cross sectional area of conductor. So we can write R equal to L by A. L is nothing but length of that object and A is the cross sectional area and R will be the resistance. Firstly, we will see how strain gauge is working. Then we will study about interfacing of strain gauge with Arduino Uno board. Firstly, you can see here a strain gauge depend on electrical resistivity, because we are saying strain gauge is nothing but use it is a sensor which can be used to measure the value of electrical resistance, and that is vary with respect to change in strain. And strain कब हो रहा है, whenever you are giving the force or pressure at that time, if there is some deformation or there is a change in displacement, we are saying that is a strain. And strain कब हो रहा है, when we are giving the force, and that force when we are giving force we are calling that force as a stress. मतलब जैसे तुम स्ट्रेस दे रहे हो वहां पे स्ट्रेन हो रहा है. स्ट्रेन मतलब क्या, एक तो उसका पोजीशन चेंज हो रहा है डिस्प्लेसमेंट, या फिर उसका शेप चेंज हो रहा है, मतलब तुम उसको डिफॉर्मेशन बोल सकते हो. एंड ड्यू टू विच देयर विल बी इंट्रोड्यूस्ड इलेक्ट्रिकल रेजिस्टेंस एंड दैट विल बी मेजर्ड बाय स्ट्रेन गेज. वो जो वैल्यू है वो स्ट्रेन गेज मेजर कर सकता है. सो स्ट्रेन गेज डिपेंड ऑन इलेक्ट्रिकल रेजिस्टिविटी ऑफ एनी कंडक्टर. The resistance in any conductor is dependent on, we have seen here, it is dependent on length and cross sectional area. So we can again write strain equal to L2 upon L1 minus L1 upon L1. Epsilon here it is used as a strain. Epsilon का meaning है strain. So we can calculate resistance equal to L by A. We can calculate resistance of object equal to L by A, and we can calculate stress as L2 minus L1 upon L1. So what are the L1 and L2? If you are giving force on any object, then we are considering, let's consider the object is having length L1. So we are saying it is the original length. And if you are applying any external force, at that time what will happen? There will be deformation. Means what? वो जो वायर का लेंथ है वो एक तो बढ़ जाएगा या फिर कम होगा. सो वी कैन से दिस इज द न्यू लेंथ. So L2 is the new length after giving the external force. So we can calculate strain as L2 minus L1. New length minus original length upon original length of that object. So we can calculate here strain. Whenever we are giving any external force on any object, at that time its electrical resistivity will change, and that electrical resistivity will be by measured by strain gauge. हम क्या बोल रहे हैं? If there is any object and you are giving force, at that time there will be change in its शेप, मतलब डिफॉर्मेशन हो जाएगा या फिर उसके डिस्प्लेसमेंट में चेंज होगा. एक तो जो ऑब्जेक्ट है वो स्ट्रेच होगा या कॉम्प्रेस होगा, फिर वो यहाँ से वहां जाएगा, मतलब वो डिस्प्लेस हो जाएगा, थोड़ा डिस्प्लेसमेंट. सो we can calculate strain, we can calculate resistance, but what we have to do, we are using here strain gauge. और strain gauge क्या करता है? Strain gauge can measure the value of electrical resistance. So there is one formula by which we can measure the value of strain. So here, whenever external force will apply on any object, its electrical resistivity will change, and strain gauge will measure that deformation of that object by using the gauge factor formula. So this formula is useful to get value at the input of Arduino Uno board, क्योंकि ये जो value है that value will be given to the Arduino board, and that value is nothing but it is the value of electrical resistivity. So here we can say strain gauge will measure deformity, and that will be in the form of electrical resistivity. So we can measure by using the gauge factor formula. The gauge factor can denote by GF. So the gauge factor is the sensitivity coefficient of the strain gauge, because we are saying strain gauge is a sensor and it is used to measure electrical resistance. So the gauge factor is the sensitivity coefficient of the strain gauge, and we can calculate by using this formula. GF equal to delta R upon RG into epsilon. Epsilon मतलब क्या है? It is the strain. How we can calculate here? L2 minus L1 upon L1, and Rg is nothing but it is the resistance of undeformed gauge. मतलब जब ओरिजिनल जो ऑब्जेक्ट है, if before applying the force the value of that resistance we can take as the Rg, that value is the resistance of undeformed. Undeformed मतलब वो स्ट्रेच भी नहीं है और वो कॉम्प्रेस भी नहीं है. तुम फोर्स देने से पहले का ऑब्जेक्ट का जो रेजिस्टेंस है, that value. And delta R will be whenever you are giving the force at that time, मतलब जो स्ट्रेस दे रहे हो, at that time there will change in strain because there will be deformation of that object. So change in resistor because of strain, and that strain it changes because of stress. मतलब जैसे फोर्स दोगे तो क्या हो जाएगा? डिफॉर्मेशन. डिफॉर्मेशन को हम क्या बोल रहे हैं? स्ट्रेन. सो there is a change in resistor caused due to the strain. This is the gauge factor. We can calculate by using this mathematical formula. Now we have to study about the hardware. How we have to interface strain gauge with Arduino board. You can see here we are using here one bridge. SG is nothing but strain gauge 1, strain gauge 2, ये SG, उसका ये meaning है. So here I am using, when we have to interface strain gauge with Arduino Uno board, at that time we are using here Wheatstone bridge with amplifier. Amplifier means what? When we have to change the value of input voltage, we can amplify and we can control the value of voltage by using this amplifier. जैसे हमने एलवीडीटी में देखा है, एलवीडीटी का जो वैल्यू है टेम्परेचर का वो कितना आता है 0 से 10 वोल्ट, बट हमारे जो ऑर्डिनो बोर्ड है, ऑर्डिनो बोर्ड में हम जो एटमेगा कंट्रोलर यूज कर रहे हैं वो कितना मेजर कर सकता है, जो एनालॉग पिन है वो ओनली 0 से 5 वोल्ट तक की वैल्यू मेजर कर सकते हैं. So here also, when you are taking the value from the strain gauge, at that time, if that value is above 5 volt, if that value is above 5 volt, then we can convert that value to the 0 to 5 volt by using this amplifier. Just because of this reason, I am using here amplifier. Then what we have to do? It's the output of स्ट्रेन गेज इज ऑल्सो एनालॉग. फिर से इसका जो आउटपुट है वो भी एनालॉग है. सो वेयर वी हैव टू कनेक्ट दैट आउटपुट, वी हैव टू कनेक्ट दैट आउटपुट टू द एनालॉग पिन ऑफ ऑर्डिनो ऊनो बोर्ड. हम क्या करेंगे, फिर से वो एनालॉग पिन को कनेक्ट करेंगे. We can connect that to the A0 pin because there is inbuilt ADC that will convert that analog value into the digital. ये बाकी the same thing when we have to interface with any system here. यहाँ इनपुट में कुछ भी रहो, ये आउटपुट में हम क्या कर रहे हैं, यहाँ पे जब हमें डिजिटल वैल्यू मिल रही है, at that time what we are doing here, we are taking that value from the Arduino board and we are giving to our CPU. So here we are using USB cable and FT232 cable. These are the transmit and receive pin. ये transmit and receive pin है. So here we can see here in interfacing of strain gauge with Arduino Uno board, which bridge we are using. This is the last topic in our second unit, peripheral interface. उसके बाद तुम्हारा टेस्ट है, असाइनमेंट मैंने क्लासरूम में भी शेयर किया है और व्हाट्सएप के ग्रुप में भी शेयर किया है. तो इस पे तुम्हें जो टेस्ट देना है तो उसमें तुम्हें एमसीक्यूज आते हैं. एमसीक्यूज के लिए तुमको इसका बेसिस पता होना चाहिए कि क्या है. व्हेन वी आर इंटरफेसिंग एनी एनालॉग सर्किट और there is any serial communication, ADC, LVDT, at that time how we are converting, what is the range we are getting from that device, and how we are converting from 0 to 5 volt, which bridge we are using, you will be needed. So in interfacing of strain gauge with Arduino Uno board, in strain gauge we are using here Wheatstone bridge. ये कौन सा ब्रिज है, we are using Wheatstone bridge. Wheatstone bridge is an electrical circuit that is used to measure unknown electrical resistance. These are the resistors. ये जो चार है SG1, SG2, SG3, SG4. These are the strain gauge 1 to 4 resistor. So this Wheatstone bridge is used to measure the value of unknown electrical resistor by balancing two legs of electrical circuit. तो हमारे ये जो यहाँ पे जो सारी जगह रेजिस्टर है, there will be one potentiometer, rheostat, we can say rheostat or a potentiometer. So we can adjust the value of remaining resistor by using that potentiometer. So here we can say we can use Wheatstone bridge to interface strain gauge with Arduino Uno board because Wheatstone bridge is used to measure unknown value of electrical resistance by balancing two legs of electrical circuit and one leg which includes unknown component. So what we can do here, we can balance the two legs of bridge and one leg whose value of resistance we don't know. We can calculate the value of that unknown resistance by using this Wheatstone bridge. So we can use that Wheatstone bridge here. So we can see here when force will apply, it will produces change in voltage. We can say this is the differential voltage. It means what? When we are applying force, at that time there will be change in voltage, and that voltage will be between 0 to 10 millivolt. It is the order of 0 to 10 millivolt. If there is no voltage, what we can say? There is a no force. And when you are giving the force, value of voltage will change, because we know Ohm's law के हिसाब से when there will be electrical resistance, V equal to IR. जैसे resistance change हो जाएगा, at that time there will be change in voltage. So whenever you will apply force, there will be change in voltage. You can see the same diagram here. But what we have to do, whenever you will get the output value from the Wheatstone strain gauge, जो Wheatstone ब्रिज यूज कर रहे हैं, उसके बाद ये strain gauge के बाद तुम्हें यहाँ पे जो value आएगा, you will need to amplify that value, because you are supposed to adjust that value in the range of 0 to 5 volt, because here we have to interface with Atmega 328 controller, and it is compatible only with analog value from 0 to 5 volt. Just because of this reason, I am using here instrumentation amplifier in order to amplify the value which we are getting from the strain gauge. So we can see here it is having instrumentation amplifier is having one negative and one positive terminal. In between, strain Wheatstone bridge is connected. Here Rg is the value of resistance, and that is used to vary the gain of amplifier. It means what? We can adjust it to produce the output voltage in between 0 to 5 volt. That value is analog. So we can give that value to the Atmega 328 controller at pin A0, because A0 पिन के वहाँ हमारे पास क्या है? एडीसी है. एडीसी क्या कर सकता है? ये जो 0 से 5 वोल्ट एनालॉग वैल्यू है उसको डिजिटल में कन्वर्ट कर सकता है, और जब वो डिजिटल में कन्वर्ट कर सकता है, we can start our programming. So we can give this to our CPU. So force applied is proportional to the strain. Strain is nothing but we can denote strain by epsilon, and strain can be defined as it is the applied force. When you are applying force, at that time there will be deformation of that object, and that deformation of object will be in the form of compression or the stretching of that object, and that changes in the shape of that object. It's called as strain. We can calculate strain as L2 minus L1, मतलब न्यू डिफॉर्मेशन का वैल्यू माइनस जो फर्स्ट लेन था ओरिजिनल लेन अपॉन ओरिजिनल लेन. So strain is proportional to the change in resistance, because we have seen here. We can calculate GF equal to delta R upon Rg into epsilon. So we can say here the value of strain is proportional to the change in resistance, and change in resistance will proportional to the change in output voltage. So we can say here this value of output voltage is depend on the value of resistance. When we are giving the force, at that time there will be change in strain. Due to change in strain, there will be change in resistance, and due to change in resistance, there will be change in output voltage, and that output voltage we are taking as an analog. So here where we have to give? We have to give to the A0 pin of the Atmega controller. So we can see here we get the value that will be converted into the digital by using here ADC. यहाँ पे ADC है, वो ADC क्या करेगा? जो एनालॉग 0 से 5 वोल्ट में मिल रहा है, that will be converted to the digital, and that will go to our CPU by using USB cable. Now we can see about the programming. In void setup function, when we have to write the program for any interfacing, we are supposed to write void setup function and void loop. In void setup function, we have to decide which per pin is working as input or output and which data type we have to use. We have to write before, but here we are not using any external parameter. What we are doing, we are only using the output of this strain gauge and we will get directly at the pin A0. तो हमें बाहर से कहीं यहाँ पे कुछ देना ही नहीं है. So what we can do here, we can assign A0 pin as the output. And whenever we are using the port, at that time we are supposed to select the baud rate. जैसे हम यहाँ का एनालॉग पिन ले रहे हैं, at that time we are supposed to select baud rate. So we can write in void setup function pin mode in bracket A0 comma output. So here A0 pin of the Atmega controller will be assigned as the output. Again, you can write serial.begin 9600. It will define the baud rate at which data will get transferred. So data हम कहाँ से कहाँ transfer कर रहे हैं? We are transferring from strain gauge to the Arduino. So we can transfer that data at the baud rate 9600. Now what we have to do? Here we have to interface. What we have to interface? Strain gauge. So we can write serial.println in bracket double quote strain gauge interface. यहाँ पे जो आउटपुट है वो कहाँ जा रहा है? A0 पिन को. But these things will happen in the loop function because in void setup function, we have to only decide which pin is working as input, which pin is working as output and what we have to do. यदि यहाँ पे LVDT रहता या फिर serial communication रहता तो हम सिर्फ यहाँ पे लिखते थे serial dot print in LVDT interface, serial communication. Then our curly braces will closed and what will happen? This setup function, the statement which we have written in the setup function will execute only once and this thing will remain constant until the life cycle of our program. After the execution of setup, the execution will go to the while loop. In while loop, what we have to do? Here we have to measure the value of, you can write here weight, you can write here displacement, you can write here deformation, you can write here resistance because that value are giving by you. So what we can do here in while loop, when your curly braces will start serial dot print weight, here that will only display that sentence, but where we will get that value? You will get that value from the strain gauge and that value will go to the A0 pin. So again what we have to write? Serial dot print analog read A0. तो यहाँ पे क्या हो जाएगा? A0 पे जो भी वैल्यू है that will be seen here. So we can use here serial dot print analog read A0. Our bracket will close. After semicolon, if you are supposed to give delay, you can give delay 1000. 1000. So here we can give 1000. After delay, your bracket will close. Here we have finished how to interface strain gauge with Arduino Uno board. Strain gauge will use to measure the value of unknown electrical resistance. Whenever you will give any force to object, at that time there will be deformation in that object and deformation is called as a strain because at that time whenever you will give force the shape will get changed. एक तो compress हो जाएगा या stretch हो रहा है तो वो डिफॉर्मेशन को हम स्ट्रेस क्या बोलते हैं? स्ट्रेन बोलते हैं और जो फोर्स देते हैं उसको हम स्ट्रेस बोलते हैं. वी कैन कैलकुलेट रेजिस्टेंस इक्वल टू R equal to L by A and we can calculate strain. Strain is nothing but it is the change or deformation in the object. We can calculate as new length minus original length upon original length, L2 minus L1 upon L1. Then we have seen about the gauge factor. We can calculate gauge factor as delta R, this is the change in value of resistance, upon Rg, the value of resistance before giving the strain. So resistance of undeformed gauge, or you can say the resistance of object before force, before strain. So you can calculate gauge factor as delta R upon Rg into explore. We have seen how to interface strain gauge with Arduino Uno board. These are the hardware description. Now you can see here we are using Wheatstone bridge because here two legs, these two legs can adjust the value of this electrical resistance, and we can give that value to the Atmega controller by using instrumentation amplifier, because we have to amplify that value and we have to convert that value into the 0 to 5 volt, because Atmega is compatible only with 0 to 5 volt. Now we can give its digital output to the CPU by using USB cable and FT232. This is the program how we have to interface strain gauge with Arduino Uno board. In setup function, we can assign A0 pin as output. So the output of strain gauge will given to the A0 pin. We can select here baud rate, and here we have to interface strain gauge with Arduino. So we can write here serial.print in strain gauge interface. If you are supposed to write whole sentence, you can write here strain gauge interfacing with Arduino. तुम लिख सकते हो. But whenever you are writing character, at that time you are supposed to write in the double quote. After end of curly bracket, your execution will go to the while loop. In while loop, you can write serial.print in wait, or you can write here the displacement or resistance. That value will taken from the output of strain gauge, and that value will go to the A0 pin. So in next instruction you can write serial.print analog read, मतलब वहाँ जो output पे value आ रहा है जो strain gauge के, that will be taken to the A0. You can give here delay by using the delay function. And at A0 pin there is inbuilt ADC. It will convert that 0 to 5 volt into the digital value. Here we have finished our second unit. If anyone is facing any issue, you can ask me. Otherwise, we can leave now. I am taking your attendance. टेस्ट है कल, सभी को टेस्ट अटेंड करना है. असाइनमेंट भी दिया है, असाइनमेंट भी सबमिट करना है. Okay. Thank you. You guys can leave now.